we're told that all of the following figures have the same height. All of the figures except for B have square bases. So that's a square base, that's a square, that's a square, and that's a square. All of the figures except for C are prisms. Yes, C is a pyramid right over here. All of the figures except for D are right. You can see D right over here is a little bit skewed, or you could view it as oblique. All of the figures except for E have the same base area. The base of figure E is a dilation of the base of figure A by a scale factor of 1.5. All right. So they tell us if figure A has a volume of 28 cubic centimeters, what are the volumes of the other figures? So pause this video and see if you can have a go at that. All right, now let's work through this together. Now, they're telling us about the bases and the heights, that a lot of these have the same base area. Figure E is going to be different. And they also tell us that they all have the same height. So one way to think about volume is it's going to deal with base and height. And so for figure A, it's pretty straightforward. If we call this area right over here, let's call that B for the area of the base. And then it has some height, h, right over here. We know that the base area times the height is going to be the volume. So we could say that based on figure A, base times height is going to be equal to 28 cubic centimeters. Fair enough. Now what's going on over here with figure B? Well, it's a cylinder. Now for a cylinder, what is the volume of a cylinder? Well, it too is going to be base times height. So it's going to be the area of the base times the height. And if you're wondering how is that possible that it's the same as the volume of a rectangular prism over here, it's actually Cavalari's principle. If they have the same height, and if at any point along that height they have the same cross-sectional area, then you're going to have the same volume. So this volume is also going to be base times height. So let me say this is figure A. Figure B, right over here, let me draw those dots a little better, these colons a little bit better. Figure B, the volume is also going to be base times height, which is equal to 28 cubic centimeters. And let me make that clear. That's the volume is equal to that. Volume is equal to that. Now what about for figure C? What is the volume going to be? What is the formula for the volume of a pyramid? And we've gotten the intuition and proven this to ourselves in other videos. Well, we know that for a pyramid, the volume is going to be equal to 1/3 times base times height. And we know that it has the same base area as these other characters here and has the same height. And so we know what base times height is 28 cubic centimeters. So this is going to be 1/3 times 28 cubic centimeters. So this is going to be equal to 1/3 times 28 cubic centimeters, which we could rewrite as 28/3 cubic centimeters. You could also write that as 9 1/3 cubic centimeters. So that's for figure C. Now let's think about figure D. I'll do that right over here. Well, for this oblique prism, I guess we could say, you're going to have the same idea, and it comes from Cavalari's principle again. It's going to have the same formula for volume as figure A. It's going to be the base times the height right over here. So I could write volume is going to be equal to base times height. And we already know what that is. They tell us the base times height is going to be the same as figure A. It's going to be 28 cubic centimeters. Now let's go to figure E. This is an interesting one because it has a different base area. What is going to be the area right over here? Well, they tell us that the base of figure E is a dilation of the base of figure A by a scale factor of 1.5. And these are both squares. So figure A will say x by x. This one over here is going to be 1.5x by 1.5x. So let me write that down. 1.5x times 1.5x. Or another way to think about it, let me do it over here where I have some free space. We know that B, which we know is the area of figure A, that would be equal to x times x. Now what's the area of the base of figure E? Well, it's going to be 1.5x times 1.5x, or 1.5x squared, which is the same thing as 1.5 squared is 2.25x squared. And we know x squared, or x times x, that is equal to b. That is equal to our original base area in all of these other figures. So the area over here, this area right over here, is going to be 2.25 times b. 2.25 times b. That wasn't so easy to read. Let me write that a little bit clearer. So 2.25 b is the base area right over here. And so what's the volume of this figure? The volume is going to be the area of the base, which is 2.25 times the area of all these other figures' bases, times the height, which is the same, times h. Now we know what b times h is, where b is the area of the base area of figure A. We know that b times h is 28 cubic centimeters. So the volume for figure E is going to be 2.25 times 28 cubic centimeters, times 28 cubic centimeters. And I don't have a calculator here in front of me, and I could do it by hand, but I think you get the general point. You just have to multiply 2.25 times 28 to get the volume of figure E. And that's because its base has been scaled in each dimension by 1.5.